Hey guys, Worm from Worm's Maths Academy. So, the feedback from everyone so far is that this exam's crap. So, they told me it's very algebraic. I haven't had a chance to look at it yet. But yeah, lots of little mistakes that can be made, and they ask you to put it in specific formats, which is usually left for specialist maths. So, let's see how we go. I don't like my chances at the moment because I've been a bit crook, so I might be slightly retarded in my answers, but hopefully everything's okay. We'll see how we go. Okay, first one. We want to find the derivative of this, which we're going to use the product rule for. So we can say dy dx, derive the first thing, multiply it by the second thing, derive the second thing and multiply it by the first thing. So we get x squared cos x. And we can leave it like that. That's it. I've got my gigantic rubber on. Okay, find the derivative of this and substitute in 1. So we know when we derive an exponential, it's the derivative of the power down the front, 2x minus 2, e to the x squared minus x, plus 3, f dash of 1, it's 2x minus 1. I thought it's not going to be 0, that'd be stupid. 2 minus 1, which is 1, e to the power of 1 minus 1 plus 3. So it's just e to the 3. It's a nice start. Okay, there's lots of words here. A manufacturer is reviewing the performance of its car Model X. It's known that any given 6-month service, the probability of Model X requiring an oil change is 17 on 20. The probability of Model X requiring air filter is 3 on 20. And the probability of Model X requiring both is 1 on 20. So let's do a car name up. Oil change, not oil change. Filter, not filter. Oil change is 17 on 20. Air filter is 3 on 20. Requiring both is 1 on 20. State the probability that any given 6-month service, Model X will require an air filter without an oil change. So filter intersects not oil change, which is this value here. So it's 3 on 20 minus 1 on 20, which is 2 on 20, which is 1 on 10. Filter, but not an oil change. They're developing a new Model Y. The production goals that the probability of Model Y requiring an oil change over a 6-month period will be m on m plus n. M on m plus n. Requiring an air filter, n on m plus n. Nice, they've got the same denominator. Requiring both is 1 on m plus n. Let's hope they ask the same thing, where m and n are positive integers. Determine m in terms of n if the probability of the Model Y requiring an air filter without an oil change at any given is 0.05. So we want to find this one here, which we know is the probability of filter intersects oil not is n on m plus n minus 1 on m plus n, which is n minus 1 on m plus n. We know that that has to equal 1 on 20, 0.05. So we get 20n minus 20 is equal to m plus n. We want to get m in terms of n, so if we bring the n to the other side, we get m is 19n minus 20. Okay, the graph shown below is part of the period of a function tan ax plus b. It's continuous from -1 to 1. You can see that in the picture. Find the value of a and b if a is greater than 0 and b is between 0 and 1. So we've got -1, -1. That gives us -1. We know y is equal to tan ax plus b. So we get tan -a plus b. And we've got 1 root 3. Root 3 is equal to tan a plus b. So -a plus b. Tan inverse of -1 is negative pi on 4. Tan inverse of root 3 is pi on 3. So we get a plus b is pi on 3. If we add 1 plus 2, we get 2b is equal to negative 3 pi on 12 plus 4 pi on 12. So b is equal to pi on 24. If we sub that into the second one, we get a is pi on 3 minus pi on 24, which is 8 pi on 24 minus pi on 24, which is 7 pi on 24. So a is 7 pi on 24. B is pi on 24. A is greater than 0. B is between 0 and 1. Okay, here we've got to bring our 2 up first because it's a log. So I'm going to say log 2 of x plus 5 squared minus log 2 of x plus 9 is equal to log 2 of 2. From this, we know x plus 5 has to be greater than 0, so x has to be greater than -5. And from this, we know x plus 9 has to be greater than 0, so x has to be greater than -9. If we bring these together, we get log 2 of x plus 5 squared over x plus 9. Because I've got a minus, we divide. That's equal to log 2 of 2, and we burn the logs. X plus 5 squared is equal to 2 x plus 9. X squared plus 10x plus 25 is equal to 2x plus 18. X squared plus 8x plus 7 is equal to 0. X plus 7, x plus 1. X is equal to -7, or x is equal to -1. However, x has to be greater than -5. Therefore, x is equal to -1. We couldn't put -7 in that because we'd be logging a negative, which isn't possible. More probability. Awesome. For a specific population, the probability of a person being born with a specific gene is 3/5. The probability of a person having this gene is independent of any other, so we know it's binomial. In a randomly selected group of 4 people, the probability that 3 or more people have that gene. So let's say X is the gene. It's binomially distributed. There's 4 people, and the probability of having the gene is 3/5. We want to know the probability that X is greater than or equal to 3, which is the probability that X equals 3, plus the probability that X is equal to 4. 4C3, 3/5 to the 3, 1/5 to the 1. 4C4, 3/5 to the 4, 1/5 to the 0. That's 4c3. We've got to times it by 27, because 3 cubed is 27, which is 108, over 5 to the power of 4, which is 625. That's 1. I've got 3 to the power of 4, which is 81, over 5 to the power of 4, which is 625. So when I add them together, I get 189 on 625. 3 to the 3 is 27. If I times it by 4, I do get 54, 108. And then if I add on 81, have I buggered anything up here? Dickhead. That's 2/5. I can't add. So we've got to times that by 2, which is 216, which means it's 297. Usually they give you ones. I don't know what I just did then. Okay. In a randomly selected group of 4, what's probably exactly 2 people have the gene, given that at least one of these people has the gene? So the probability that 2 people have the gene is 4c2, 3/5 to the power of 2, 2/5 to the power of 2, which is 4c2, 14641 from Pascal's triangle. I get 6 times 3 squared times 2 squared on 5 to the power of 4. Which we know, 6 is the same as 3 times 2, so we could have 3 cubed times 2 cubed over 5 to the 4. Don't know if we need to use that, but let's see. Oh, that's the same as 6 cubed. Pretty sure. Okay, the probability that x is greater than or equal to 1 is 1 minus the probability that x equals 0, which is 1 minus 4 choose 0, 3/5 to the power of 0, 2/5 to the power of 4, which is 1 minus 16 over 625. Okay. Which is 1 minus 2 to the power of 4 over 625, or 5 to the power of 4. Stuff it. Let's just do it with numbers. If I take 16 off that, I'm going to end up with 609. So here we could say 625 over 625. We could join them together, put a negative in the middle. We know that's 5 to the power of 4. We know that is 5 to the power of 4, and we know that's 2 to the power of 4. The probability that x equals 2, given x is greater than or equal to 1, is 6 to the power of 3 divided by 5 to the power of 4. That's the probability that x equals 2. Over 5 to the power of 4 minus 2 to the power of 4 over 5 to the 4. They cancel each other out, and we end up with 6 to the power of 3 over 5 to the power of 4 minus 2 to the power of 4, which is what we wanted. It's a bit stupid. Okay, find the domain and range for the rule. So here, if we know our domain is 0, we know our range is going to be 0. If I put 2 into that, I get 1 on root 2 times root 2, which is just 1. So, to find inverse, let y equal f of x, swap x and y. X equals 1 on root 2 root y. Root y is equal to root 2x. Y is equal to 2x squared. So f inverse of x is 2x squared. X is between 0 and 1. Okay. The graph of y equals f of x is shown. On the axis, sketch f of x, f inverse of x over its domain. So we know if that's the point 1, 2, it's got to go through 2, 1. And it's going to be a reflection in the line y equals x. That'll do. So we know that's going to be a half. That's going to be 1, 2. Sketch it over its domain, label the endpoints, points of intersection, giving their coordinates. Okay, we've done all of that. Find the total area of the two regions. One region bounded by the functions f and f inverse. The second one bounded by f inverse and the line x equals 1. Stupid thing. Okay, so that's that area up there. It's kind of annoying because you've got to do two graphs. So our area is from 0 to a half of one on root 2 x to the half minus 2x squared dx plus from a half to 1 of 2x squared minus 1 on root 2x dx. Now, we can effectively make these the same by taking a negative out in the second one. So what will be in the integral will be exactly the same thing. So that will give us an edge in that we're not going to have to do stuff twice. Okay, I've got 1 on root 2. If I antidiff a half, I get 3 on 2, which becomes 2 on 3 out the front, x to the 3 on 2. And then, if I antidiff that, I get minus 2x cubed on 3 between a half and 0. Minus. Now, let's clean this up. If I've got a root 2 on the bottom, I can multiply the bottom and the top by root 2. That would disappear. Like if I multiply this by root 2 over root 2, they will cancel with that. So I end up with root 2 on 3. So root 2 on 3. This bracket's exactly the same. Root 2 on 3, x to the... Here I'm going to write x cubed square rooted. And here I'm going to write the square root of x cubed minus 2x cubed on 3 between 1 and a half. Okay, if we sub a half in the first bracket, we get root 2 on 3 times, if I cube a half, I get an eighth, and if I square root it, I get 2 root 2, so I get 1 on 2 root 2. If I cube a half here, I get 1 on 8. So I get 2 on 3 times 1 on 8. If we sub 0 in, we get 0 because it's a polynomial. So we know here that will cancel with that. 1 on 6. That will make that a 4 minus 1 on 12. So that's our first one. We next need to substitute 1 into this, which should make it a fair bit easier. Because I get root 2 on 3, because 1 in that's just 1, minus 2 on 3. Then if we sub a half in, we just get whatever we got in the first bracket, which I'm going to say here, the first bracket, we got 1 on 12. So we know they're exactly the same. So we get minus root 2 on 3 plus 2 on 3, because that minus minus. I've got minus a 12th times minus, so I've got plus a 12. We now need to get a common denominator. So let's have a look. I know the first bit is 1 on 12. I've got minus 4 root 2 on 12. If I put that on 12, it becomes 8 on 12 plus 1 on 12. So we get 10 minus 4 root 2 on 12. We can take out a common factor of 2 on top and cancel it with the bottom. So we get 5 minus 4 root 2, 2 root 2, you dumbass, over 6. Because I've got to take out 2, we get 5 minus 2 root 2 on 12. They cancel. So that's our answer. A minus b root b, 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 they're the same, and on 6, so that's perfect. Okay, how many questions are there? I haven't got the front cover, so. End of exam. 8. It's usually bad because it means that the questions are quite long. Okay, consider the graph of f of x equals x squared plus 3x plus 5, and the point P10. Part of the graph is shown below. Show that P is not on the graph. So, f of 1 is 1 plus 3 plus 5, which is 9. F of 1 does not equal 0. Therefore, P10 doesn't lie on the graph. And that makes sense because 1, 0 would be over here. And if you look at that graph, it looks nothing like it. Consider a point Q, AF of A, to be a point on the graph. Find the slope of the line connecting the points P and Q. So let's say it's here. That's going to be the point A squared plus 3A plus 5. I want to find the gradient of the line connecting those 2 points. So M of PQ is A squared plus 3A plus 5 minus 0 over A minus 1. A squared plus 3A plus 5 over A minus 1. Find the slope of the tangent to the graph of f at the point Q in terms of A. So here we want the instantaneous gradient. So f dash of x is 2x plus 3. So f dash of A is 2a plus 3. Let the tangent to the graph at f of x equals a pass through the point P. So wherever our tangent is, it's got to pass through there. So these two lines have to have the same gradient, which means they have to be equal. So we can say a squared plus 3a plus 5 over a minus 1 is equal to 2a plus 3. A squared plus 3a plus 5, I don't know why I bracketed that, is equal to a minus 1, 2a plus 3. A squared plus 3a plus 5 is equal to 2a squared plus a minus 3. A squared minus 2a minus 8 is equal to 0. A minus 4, a plus 2, a equals 4 or negative 2. Find the equation of the lines passing through the point P that is a tangent to the graph of f. Well, we just worked out those points. When a equals 4, f dash of 4 is 2 times 4 plus 3, which is 11. When a equals negative 2, f dash of negative 2 is 2 times negative 2 plus 3, which is negative 1. What else do we need? We've got the point 1, 0. Y minus 0 is equal to m, x minus 1. So y equals 11x minus 11. Y minus 0 is negative 1, x minus 1. That's also using the point 1, 0. Negative x plus 1. So there are two tangents that pass through those points. Find the value of k, the shortest possible distance between the graph of the function y and f of x minus k and the point P. So we want to find the shortest distance, and we're moving this graph left and right. So there's the distance between the graphs. But I want to make it a minimum, and I can move the graph to the right. So I want to grab that turning point, bring it over to here, because that's when the shortest distance will occur. So we've got f of x equals x squared plus 3x plus 5, which is x squared plus 3x plus 9 on 2, minus 9 on, that's a 4, minus 9 on 4, plus 20 on 4, x minus plus 3 on 2, squared, plus 11 on 4. So that's the turning point of the graph now. 3 on 2, what was it? 11 on 4. We want to move it across to the point 1. So we've got to move it 2.5 units to the right. So we need to translate right 5 on 2 units. Therefore, we know that k is equal to 5 on 2, because the minus is automatically going to move it to the right. Okay. I've seen a similar question before. I used it on a practice sack, I think, with the kids. Okay, the graph has a minimum point at A, f of A as shown above. Find the coordinates of the point Q. Well, we know it's a turning point. So if f of x is x log ex, f dash of x, derive that, we get 1, times it by log ex. Derive the log ex, we get 1 on x, and times it by x, we get log ex plus 1. We know f dash of x equals 0 for a stationary point. So we get log e of x plus 1 is equal to 0. Log e of x is equal to negative 1. X is e to the negative 1, which is 1 on e. So the point Q is 1 on e. If we sub 1 on e into log e, x log e, 1 on e, we know that that's e to the negative 1. And we know that log e of e is just 1. So that point is negative 1 on e. Using the derivative of that is equal to that, show that when that has an antiderivative of that. Okay, so you can see here that that's my bit that I'm looking for. I'm going to let f of x, let's let h of x equal x squared log e of x. So then we know h dash of x is 2x log e of x plus x. If I bring my x to the other side and divide it by 2, we can say x log e x is equal to h dash of x minus x, all divided by 2. Therefore, if I want to antidiff x log e x dx, it's the same as antidiffing h dash of x minus x dx, which is a half of h of x minus x squared on, it'd usually be on 2, but because I've got a half out the front, it becomes x squared on 4, which is a half x squared log e x minus x squared on 4, where c equals 0, because it says an antiderivative. Okay, the area of the region that's bound by the line F, the line x equals a, and the horizontal axis for a to b, where b is of the form x, where b is the x-intercept of f. So we know that's 1 on e. If we've got x log e x equals 0, x equals 0, or log e x equals 0, so x equals e to the 0, x equals 1. So we want to find the area in here, which is from 1 on e to 1 of x log e x dx. Now we know what the antidiff is because we just did it. So I'm going to say x squared on 2 log e x minus x squared on 4 between 1 and 1 on e. When we sub 1 in, we get a half log e of 1 minus 1/4. I just read, this just says the area. So we've got to put that as a negative. So remember that at the end. And then I've got minus. When I put 1 and e in here, I get 1 on 2e squared log e, I'm going to say e to the negative 1, minus, when I put 1 on e in here, I get 1 on 4e squared. Okay, we know that's 0. So we've got negative 1/4. That there is the same as making that negative 1 on 2e squared. So I end up with plus 1 on 2e squared. And I end up with plus 1 on 4e squared. Now let's put them all over a common denominator. 4, that becomes a 2. E squared. When we add them all together, that becomes positive e squared on 4e squared. That becomes 3 on 4e squared, but it's negative. So our area is e squared minus 3 on 4e squared. Okay, we're nearly there. I have no idea how long this has taken. For this function from a to g, the graph of f of x plus k. So g is the same graph as this, but it can be translated up and it can be translated down. Find the value of k for which y equals 2x is a tangent to the graph of g. So the gradient has to be 2 on both of the graphs. Because that's got to be a tangent. So f dash of x, we've worked that out, haven't we? Log ax plus 1. That has to equal 2. Log ex has to equal 1. X has to equal e to the 1. If x equals e, y is equal to 2e, because that's got to be the tangent. So when I sub e into it, my equation has to pass through 2e. Find the value of k for which y equals 2x is a tangent to the graph of g. We know that this graph here has to pass through e and 2e. So we can say x log e x plus k equals y. Therefore, e log e of e plus k is equal to 2e. So I subbed in x equals e and I subbed in y equals 2e. We know that's 1. If we subtract e from the other side, we get k is equal to e. So if k is equal to e, y equals 2x is a tangent to the graph of g. Find the values of k for which the graphs of g and g inverse do not intersect. So this one's going to be a bit hard to explain, but basically we know if this is g, g inverse will look like that. As I move this graph up, this graph here is going to move to the right. And there's going to be one point where they intersect, and that's going to be on the line y equals x. So what we can do is say, when does this graph equal the graph of y equals x? Because that'll be where they intersect. So I'm going to say, let g of x equal x. X log e x plus k is equal to x. Therefore, we know k has to equal x minus x log e x. Now, if we want it to intersect once, this function will only have one solution. Because if it's up and it's turning, if they intersect once, it's when your graph has one point. So we've got to find when the turning point is equal to 0. So let's let this, let it equal, not k of x, let's let it equal m of x. Let m of x equal x minus x log e x. M dash of x is 1 minus, if we derive x log e x, we know that we get log e x plus 1. Leave that, derive that. 1 on x times x. And we know that has to equal 0. So if we let m dash of x equals 0 for the turning point, they cancel. So we get log e x is equal to 0. So x equals e to the 0, which is 1. When x equals 1, k is equal to 1 minus 1 log e of 1. So k is equal to 1. So when k is equal to 1, that would be when this graph and then this graph would just touch. As k increases, this graph's going to go upwards and this graph's going to go to the right, which means that when k is greater than 0, k is greater than 1, there are no solutions. So when it's equal to 1, it's when they just touch and intersect. But when it's greater than 1, this graph's going to move up, this graph's going to move to the right. And let's have a look. If I go into graphs, x log e, x plus k, we'll say a. Yes, I want to insert a slider. I've got to put a times in between. Okay. So you can see as we move the value, this graph moves up and down. So as k gets larger, it's going to move further and further away. We can't get the inverse because it won't allow us to, because we've got a log function and mixed function. But you can see as k increases, if we were to sketch its inverse, you would see that they break away from each other and you're not going to have any solutions. So k has to be greater than 1 for there to be no solutions. hopefully that was helpful. Pretty tedious exam. Don't know what to think of it, to be honest. You got to have good algebra skills, but yeah, other than that, I don't know what to say. It's different. Hope you did well. Bye.